Okay, so hi everyone. I'm gonna talk about my project. Topic is decentralized and privacy enhancing WebRTC framework for secure peer-to-peer communication and telemedicine. So I'm actually gonna build or I built a prototype of a product. It's a website that allows the communication peer-to-peer and also um, uses the different framework that is accessing to a signaling server and then communicate. This can be this can be something used in telemedicine because when there is a patient and a doctor that wants to get in contact, a video conference or video call is needed for this telemedicine. Okay, so I'm gonna go through this. I'm gonna go through what is telemedicine. I'm gonna talk about the peer connection. What is a peer connection? The benefits of it. Using WebRTC. What is WebRTC? How it works? The security that it has in encryption and in what are the problems like with leaks, and also the challenges of this project, the challenges of WebRTC, and conclusion. So, what is telemedicine? Well, telemedicine is remote healthcare using technology like video calls or messages. It allows patients to consult with healthcare providers without in person visit, making healthcare um, more accessible, especially for those in remote areas with mobility limitations. The use of telemedicine has grown significantly, especially in recent years, driven by advancement technology, increased internet accessibility, and the need of a remote healthcare solution, as demonstrated during events such as COVID-19 pandemic. So one of the characteristics of one of the benefits of telemedicine is the accessibility. Telemedicine eliminates geographical restrictions that can stop a patient from visiting a doctor. Also is convenience. A telemedicine services give patients more flexibility, comfort, and convenience, reducing waiting times and minimizing interruption to their daily schedules. Is it cost effective analysis? Um, Telemedicine save costs by cutting travel expenses, reducing overhead for health facilities, allowing the earlier intervention, and improving access to specialist care without a need of a costly travel. And also continuity of care. Telemedicine is used for follow-up care where physical exam is not necessary. Also, this can help people and patients who are facing chronic diseases be monitored and just through a call or through a message. And the personal attention, sorry. Um, like this allow the professional to communicate directly face to face with the patient, and these services are personalized and individual for each for care. Okay, so what is a peer connection? Peer-to-peer connection or communication refers to a decentralized form of communication where two or more devices or users directly connect and communicate with each other without relying on a central server. In this type of communication, each device can act as a client, as a server, enabling direct exchange of data files, data, messages, or even like media without any intermediary. Peer-to-peer communication is commonly used in applications like file sharing or video conferencing like WebRTC and messenger services. So we have here two models. One is a client server. This is a centralized communication and a peer-to-peer communication. In a centralized communication, well, the client is gonna um, is going to communicate with the client 1 is going to communicate with the client 2 through a server. Client A is going to send a message to the server is going to reach the client 2. The client 2 is going to send a message to the server is going to reach to the client 1. And this could happen, well, as we don't realize like the latency, it could happen like latency of 1 second. Uh, However, for some application, this 1 second can be important. In peer-to-peer communication, like the communication is gonna be between client and professional, between client 1 and client 2, the patient and doctor, without the intermediate of a server. Okay, and then what is WebRTC? Well, WebRTC stands for Web Real-Time Communication. It is open source that enables the time communication directly between web browsers of mobile application using application programming interfaces or APIs. Well, it allows the peer-to-peer communication of video, audio, screen data sharing without the need of any software, without the need of any additional plugins thing. It's supported by major browsers, including Google Chrome, Mozilla Firefox, um, software, Microsoft Edge or Opera. And it's accessible for developers to implement because it's open source. And yes, so what are the benefits of WebRTC? Well, it secure the peer-to-peer communication. Um, Direct communication between peers enhances privacy and security as data is transmitted directly without intermediate. Real-time communication of audio, video, easy to use. Real-time communication technology is user-friendly and accessible, requiring minimal setup of or technical knowledge for users to initiate and participate in conversation. Low latency and high quality. These systems prioritize low latency and high quality of video transmission, ensuring a smooth and uninterrupted interaction. As a platform independence, it doesn't need the use of another platform, another software, and it is okay. Integration with web technologies can be seamlessly integrated into web application just using the APIs like WebRTC, enabling developers to enhance user experience and engagement. And cost-effective solution eliminates the need for expensive hardware of infrastructure, offering cost-effective solutions for businesses and individuals seeking to connect and collaborate with others. So the important parts of WebRTC are the media access of media streams. This is going to be the inputs and outputs of the camera and the audio. The system asks for permission to the user so they can use this media. The media stream API controls the streams of the media where each one have their input and their output. The input will refer to the hardware such as camera, microphone, and yes. The peer connection, these APIs will make it easy for web browsers to connect directly to another one through a peer connection. The peers will be able to send and receive media streams. The peer connection will use ICE candidates and stone servers. Okay, and what is the signaling? Well, the signaling refers to the process of coordinating communication between peers to peers, the device, in real time. It involves exchanging metadata or control messages that facilitates the establishment, maintenance, and termination of connection. Signaling is crucial for WebRTC because WebRTC itself does not define how to set up communication channels. So you can actually just communicate from one end device to the other device if you have this SDPs, the session description protocol. But it's not safe just to copy the session description protocol that is a bunch of code and paste into someone and that person to open it in the browser and then get the communication. So the signaling is very important because it provides security and it also provides reliability in the communication, and it make it more automatic. Okay, and the ICE frameworks or the ICE candidates will contain information needed to establish the communication. In this case, it's gonna be the IP address, and also it's gonna be the port to be access of to be accessed. Like if someone want to access to the client one, the ICE candidate is gonna contain like the public IP, and also it's gonna contain the ports that can be accessed. The ICE candidate is gonna be known from the Stone server. The Stone server is gonna bypass the NAT, that is the network address translation. So it is used because the public IP is gonna identify the network, but every single device has their private IP inside the network. Okay, and what is a SDP that I was telling you? So this message contain session details, like if it's an offer, if it's a request, sorry, it's an offer, if it's an answer, it's gonna contain the media types like the codecs, and also contain the transport protocols, enable them to agree on how they're gonna set up a connection. And well, yes. So here we have an architecture of WebRTC. So how it works. Well, first of all, we know that client A wants to communicate with client B, and they cannot do it without a signaling server. So the signaling server is gonna allow this communication, and then after the communication have is being established, it's gonna stop working, and the client A can communicate with the client B. So let's take this case. We have client A as the patient, and then we have client B as the professional. So client A, the patient is trying to access to the professional through a website that has like a video page. And for this, it's gonna first access to the audio and access to the camera. When this is access or pull up, the peer-to-peer connection is established or started. And then the client one communicates with the Stone server and asks for information about its public address for establishing connectivity. So the Stone server responded with a nice candidate, facilitating direct communication between clients. So the ICE candidate is gonna bring with a public IP, and is also is gonna bring the ports. Okay, so the media track are added to the SDP, that is the session description, and also is going to be added the ICE candidates. So client one generates an offer that is going to contain, as we say, the data of the address, the data of the session, and also the data of the port. And then there's gonna be establishment of communication. It's sending to the signaling server. The signaling server is gonna send to the client. Sorry, from socket.io. The client is gonna be always listening. So there's gonna be recognize that someone wants to communicate, and he recognizes someone wants to communicate and ask to the server like, can you send me my ICE candidates? But before of that, he also access to the media, camera, and audio. And now, after getting the ICE candidate, create a session decryption protocol that is going to include the ICE candidate, the type of session that is going to be our response, and it's gonna and also the media is gonna send to the Signal server. The Signal server is sending to the client one again, and then it put like in local, it put the session description protocol as an offer. Remote the answer, and in the other side the same. Remote the answer from the client one, and local the one from the client two. Okay, so then the communication is established. The communication between client 1 and Signal server is going to be a TCP because we need reliability in case there is a loss of package or data in the way. So it's going to ask again for the data. And well, with this, the Signal server stopped working. And the client 1 can communicate with the client 2 through peer-to-peer. Okay, and after this, what are the security of this? Why we say that WebRTC is secure? Why we say that WebRTC, like the peer-to-peer communication, is secure? So, first of all, the encryption is crucial for WebRTC. It's a mandatory that WebRTC have encryption. It's gonna work in HTTPS. So as a mandatory, if you don't use HTTPS, if you don't have the certificates of secure connection, it's not going to work by default. Okay, so there are multiple layers of security with RTC. We have SRTP protocol that secures the encryption key. They secure the encryption. We also have a security encryption key exchange and a security signaling. So the SRTP protocol is going to encrypt the communication, is going to encrypt the audio and the video, but it doesn't provide any managing of the keys. So then it's going to be used at DTLS SRTP. That is a protocol that will make sure that the exchange of the keys will be encrypted to secure the streams of audio and video. And in this, with this, the professional or the client too will be able to decrypt the data. Okay, so DTLS is based in TLS that provides similar security for the datagram and the UDP. Okay, HTTPS will be the protocol that protects the connection to the Signal server, also to access to the web server. This will protect the connection, secure even if the connection is not established inside the security measures of the system. Like HTTPS is going to protect the communication on the browsers. Also, like when you access or you grant permission of using your video and your audio, that's another kind of security layer. This operative system also provides a security layer. And then we are going to talk about the WebRTC leaks. So there is our vulnerabilities in the connection. As we know, WebRTC, the communication bypass the security measures for from the firewall and from the NAT, and this is because they want a direct communication or direct connection. And this can cause potentially exposure of the IP public address via WebRTC, and this can be a big problem because if someone gets to know your public address, they can know where exactly are you located, like your geolocation. They can also use that for some of the attacks like man in the middle or fingerprinting or flooding the web and also like exploring the devices that are connected to your web. So one of the problems with this, as I say, is the man in the middle. And one of the solutions for man in the middle is to add to the DTLs, like we see, add to the DTLs an identifier, like who is sending this. And if the signal server doesn't recognize that identifier, then it's not gonna is going to prevent that connection. Um, so these WebRTC leaks are undetectable by blockers or VPNs. Actually, when I prove it, I use a VPN, and it was still like showing me my public address. So as a consequence of these leaks, the anonymity, sorry, the anonymization of the client or of the end device, and the exposure of ISPs. Um, so one of the vulnerabilities, it's also like these sites have like the structure of the page that is going to contain the JavaScript is also going to be the same server that is going to be in charge of the signaling, in this case the Socket.io server. And if someone has full access to that server, it can corrupt the JavaScript and then can create a leak that allows you to connect to the signal server, and then can cause a man in the middle. Also, as I say before, like knowing the IP can cause like someone explore the local network, know which devices are connected and their IPs. So what are the challenges of this system and this project? So, well, we know now that WebRTC has a lot of challenges and obstacles. Some of them are related with the privacy and the risk. Um, Also, like we're gonna say, like there should be a regulatory compliance and technical protocols to avoid these privacy concerns at the time of development or deploying, or just like to planning a project. We know that there is no standard signaling protocol, so that relies on the developer. The encryption is these WebRTCs have encryption and secure signaling until JavaScript is corrupted, or if the IP is leaked. Yeah, so WebRTC works with UDP, but the UDP is not reliable for communication. Like if data is lost, it's not gonna be good. So it will be good for video and audio, but for messages or for sending the files, there should be used like WebSockets. Okay, the prevention. One of the challenges also, like, it's how to prevent the data leakage. As we see, there are some options to do it. There's some plugins, there's some extensions that can be used to this. Also configurations for the web servers, sorry, for the browsers. The security measures for authentication and telemetry. Okay, so one of the security measures that could be added would be like, now in the system there should be an authentication process. Like, okay, put your username and get inside your account, like start your account to start like the communication. We know that it has layers of securities because it works with the browser. So it has like the HTTPS, it has also the browser security, it has the operating system security, and it has like the security from the server, from the server, like AWS in this case that I use. It was tested in different systems. What I mean, like in different operating systems. It was tested in Android, it was tested in Windows, it was tested in Ubuntu. and with different also browsers, and some of them show like there was able to do a communication, some of them didn't allow me to start a communication. And one important fan of this is that iOS and Safari doesn't work with WebRTC, and as we know, like in US, most of the people use iOS and use iPhone, so that would be a problem to implementation. Um, in a country like this. Some plugins are going to be needed for iOS. It says that new versions supports WebRTC. However, I was not able to test it. As I say, here is a table where you can see like the compatibility of some of the browsers. So Chrome and Opera work perfectly. Edge also, Firefox have some problems, and Edge and Safari cannot. So where the conclusions? The conclusions are like decentralized frameworks really enables like real-time communication, and this helps like overcoming geographical barriers and enhancing security by reducing reliance on centralized servers. Um, Healthcare costs will be lower, or businesses or companies' costs will be lower by eliminating physical appointments. Sorry, by eliminating the use of a hardware of software. And also, like in healthcare, eliminating physical appointments will lower the cost even for the providers or the patient. WebRTC offers easy to use browser compatible communication because you don't need to install any plugin or anything. But if you want to make it more secure, as I said before, then it's going to be a need to install plugins or change the configuration. There is a mandatory encryption. You have to use HTTPS, and you have to use SLS certificate, so your connection can be secure. This is a mandatory. If you use a HTTPS web page, it's not going to work. And well, one good thing of WebRTC is that this real-time communication reduces latency and improves system responses. IP addresses leak. This is a risk for it. Um, and mitigating the leaks, it's really important in the security of the system. So we need to use proper security protocols for the signaling. We used to use security protocols for the Stone server. And yes. So what I did next was to show how it works. Okay, so first this is gonna be in the local host in the computer. Then we're gonna see a real-time example. So we generate a link, as I said before. This link is gonna be generated by the system. The system is gonna send to the client, and the client is gonna paste this link, and it's gonna obtain, yes, what is this, a main page where you can see join audio, join video. So if we do this, then it's gonna be like that, and also the hang up button. So then from the other side, okay, we're gonna start like, we're gonna mute and we're gonna start. Okay, so the video is gonna be there. And then from the other side, the doctor is gonna say, okay, what is happening in me? Oh, I got a request that someone is trying to examine me, so I join it. And then I start the same. I start the join audio and I start the video. And then the communication starts. If I turn off this camera, the other person is not gonna be able to see me. If I turn on, then it's gonna be still there. So then we hang out, the communication is cut. We hang out from this side, the communication is cut. So now we're gonna see a real-time communication. Okay, so now I think what I'm gonna do is to prove the connection in real time. So the system is deployed in AWS, and in Ubuntu machine and uses Apache to connect inside like to the right HTML. So we have the API. The API is gonna use the Docker Express, and it's gonna be for creating the links, for validation the links, for connecting to the other peer. And then, well, I'm gonna copy this link. And I'm gonna send it to someone that is not in Virginia. And then, wait, I'm gonna wait for someone to appear in the connection. And the other side, but the doctor is there. The doctor is in the dashboard. The dashboard is the information of the patient. And then I'm gonna wait for someone to appear, like the incoming calls. And voila, a message was popped. Someone is trying to connect. So the doctor plays join, and then we have a message like the doctor is gonna also access to the join audio and start the video.
Oh,
Voila, we have the connection here. Yes, so I'm gonna
I
ask
can
you
hear
like,
you. Right now, we are checking the communication quality. Right now, I just joined to the video meeting with your link. And right now, I am located in New York. Can you?
yes, I
Yes,
can
I can
hear
hear
you.
you.
And can you mute and unmute?
Yes, I can. Okay.
Can you stop your video and start your video again?
Uh, I think you are mute.
Or can you start your video and
No.
and stop your video?
Video? Yeah. Okay.
Go
And go
back to
back
your
to your
video.
video.
Okay.
Okay.
And
And
now
now
can you
can you
hang up
hang
the
up the
call?
call? Okay. Thank you. See you. Bye.
Thank
Thank
you.
you.
Okay, so
Okay, so
when the
when the
call
call
is
is,
when
sorry.
the call is hang up, from one side the screen freezing from the other side also. So if I hang up the call, both of the screens are disappear. And that's all. If we see like from the spec, we're gonna see how the signaling connection became. Like we're gonna see that we got the candidate, the ICE candidate. We also got like the track and some messages that we need for this. And as a last point, I'm gonna explain a little bit that I tried to track the connection with Wireshark, and I got some of the connection, like the a handshake that exists between the client and the server, and also the access to the DNAs, the Stone server here. Um, the Stone server requests and the Stone server responses with the information. And if we see here, like um, the router was trying to look for the address so it can connect. Like, who is this address, right? With the ARP protocol, then there's a ICMP that is looking for someone, and again, like it's asking until it get like a result, and then the connection start. So we have like the DTLS that will help with sending the code, sending the encryption keys. Then after the signal server is done, like this, this is done. So we're gonna start on UDP. The UDP is gonna bring the the data of the video and the audio, and then it's gonna be the communication is gonna be just to the UDP. So the UDP is gonna have um, entrance, and it's gonna have a message outgoing and incoming, like someone is sending something, I am receiving this, I am sending these, they are receiving these. Um, and yeah, that's all. And it's showing that it's working. It's showing like audio, video works, mute and unmute. To show is also like here you can enable or disable like some of the devices and choose like your camera and that. Uh, and yes, thank